Hello all, welcome back to the channel and welcome to the official YouTube channel of Harak Coaching Classes. We are discussing trigonometry of class 10th ICSE board, and today we are going to cover some previous year board examination questions based on trigonometry. So let us start our journey with this first question. So question first, we need to prove that sec a minus 1 over sec a plus 1 is equal to 1 minus cos A over 1 plus cos A, right? So how to do this? See, so in these kind of questions, when we have the proof kind of thing, we need to think over that how do we start with? So either we can start with LHS, move to the RHS, or either we can start from the RHS and move to the LHS, right? So either we can start from this, move to this, or we can start from this, move to this. So we have to think for a better option that what is fast and how do we see that? See, so we can start with the here in this question, we can start with the LHS. So if we start with the LHS, then how can I write sec A? So we know that sec A is the reciprocal function of cosine A. And if secant of A is reciprocal function of cosine of A, that means 1 over cos A is written in place of sec A and minus 1. And that similar ways 1 over cos A plus 1, right? So now if I take the LCM, the least common multiple, then it would be 1 minus cos A over it would be 1 plus cos A, right? And that is intact we need to show. So that is how we have done the math. So this question which I have just now talked is from ICSC board 2007, right? Okay, now coming to the next question. See, next question is basically 1 minus tan square or tan of A whole square plus 1 plus tan of A whole square, and we need to show it equal to 2 sec square A. Now see, remember the last class when we talked about Pythagorean identities, and we have seen that basically sine square A plus cos square A is 1, 1 plus tan square A is sec square A, and 1 plus cot square A is equal to cosec square A, right? So this way we have to apply the identity. So now here, what is the thing? See, there are two ways to approach to the problem. See, the one way is to actually what? Use the identity first of all, a minus b square and a plus b square. So what is the identity for the a minus b square? What is the algebraic identity for this thing? So for this would be a square minus 2ab plus b square. And for this, that would be a square plus 2ab plus b square. Now coming on that, so if we apply this to basically that thing, that 1 minus tan a whole square, this complete expression can be written as 1 plus tan square a minus 2 tan a. And then similar to that, 1 plus tan a whole square could be written as 1 plus tan square a plus of 2 tan a. If I combine these two as a form of the question, so it would be 1 plus tan square a plus of 2 tan a plus of 1 plus tan square a minus 2 tan a. So this 2 tan a goes off with 2 tan a, and then 1 plus tan square a plus 1 plus tan square a would become 2 plus 2 tan square a. 2 is common in both, so it would be 1 plus tan square a, and then this could be equal to 2 of sec square a, right? So then this way we have showed it equal to RHS, and hence we have done with the proof. Now the another way to solve the same problem is what approach? See. So another way to solve the same problem is to just write this tan A in terms of sine A over cos A. And then what is the idea? We just simplify the LCM and then solve it, and you will be getting the same answer as 2 sec square A. So that is another question, and this question basically is from ICSC board 2005. Okay, see now the next question. See, so the next question, question number third, is sine of A over 1 plus cos A is equal to cosec A minus cot A. Now, see, told in the very beginning of the lecture, I have told you that either we have the option to move from LHS to RHS, or we can move from RHS to LHS, right? So either we have an option to move from LHS to RHS, or either we have the option to move from LHS, RHS to LHS. So here, I think we have to convert this into sine A over 1 plus cos A, and we cannot convert this sine A over 1 plus cos A directly to cos A minus cot A. So what is the idea? We start with the RHS and we will come to LHS. So let's say if I start with LHS, and why is we have started with the RHS? Because we know that cosec A and cot A could be easily converted to sine and cos in terms of sine and cos, so that we have the sum factor, so that we can somehow reach to the LHS part, right? So 1 over sine A over cos A over sine A. Now coming to this, what is the idea? I can write 1 minus cos A over sine A, right? Now, in order to convert this into this, what is a common thing? You can see if I multiply both sides by 1 plus cos A over 1 plus cos A. And you might have a question like, sir, why you have done this 1 plus cos A multiplication? So you could see that in denominator, what we want 1 plus cos A. So in order we are getting 1 plus cos A, we have multiplied by 1 plus cos A. So as soon as I multiply both the terms by 1 plus cos A, the above term would become 1 minus cos square A over sine A times 1 plus cos A. And now remember the identity, sine square theta plus cos square theta is 1. So 1 minus cos square theta would be sine square theta. So then this thing can actually be converted to sine square A over sine of A 1 plus cos A. And then this sine A, it goes off with this. So we have the answer sine A over 1 plus cos A, right? So this is how we have done the question number 3. And this question actually is from ICSC 2008. Okay, now the fourth and the last question of today's class would be about 1 minus cos of A over 1 plus cos A, take it whole under root, is equal to the same RHS from the previous question, which is cosec A minus cot of A. Now this time actually think that can we start with RHS? So the absolute answer is no, because if we start with the RHS, it's impossible to make something a number to a root thing, right? So then what is the idea? We start with the LHS side. And we know that if we are starting with the LHS, and if the thing is inside the radical sign or the root sign, then it will be always be converted to a radical free denominator. That means I need to multiply the denominator and numerator by 1 minus cos of A, right? This way. Then if this is the case, then above fraction, above numerator would become 1 minus cos square, and below it would become 1 minus cos square A. And then above cancel with the root, so it would become 1 minus cos A, and below it would be, see how much? So 1 minus cos square A would be sine square A. So under root of sine square A, And then once we remove the under root with the square sign, so it will only left out to sin A. And then we just separate the denominators from the numerators. So then separating the numerators individually, we got 1 over sin A as cosec A minus cot A. And we have actually showed that this is equal to the RHS. That means, hence, proved, right? So we have done in today's class the four board problems, and this problem which I have just now done is of the problem ICSC 2000, right? So it was from the year 2000, right? So we have done the four major problems based on the trigonometries and based on the previous lectures what we have done the identities. So we have used those identities and used the logic of trigonometry to solve four board problems, right? So stay tuned for more such lectures. We will be covering more board problems in the next class, probably. So stay tuned, stay connected. If you like the channel, subscribe it, and if you like the video, share it with your friends. Thank you. Have a great day.